Welcome to Ask and Learn.
So they want us to figure out how many weighings on the balance scale are needed to find a counterfeit coin. But all we know is that the counterfeit coin doesn't weigh as much as the others. So we don't know if it weighs less or weighs more as in question 6. And then they want us to give an algorithm to figure out which one of these coins is counterfeit. So let's go ahead and set up the situation. So let's say we call the coins just 1, 2, 3, and 4. So we have our balance scale here. And what we're going to do is just put coin 1 here and coin 2 here. So we have two cases. So case 1, we have that coin 1 is equal to coin 2 weight. So they weigh the same. So in this case, what we're going to do then is take coin 3 and then weigh it against one of these. So it doesn't matter which one we weigh it against. All it matters is that we weigh it. So I'll just say we took 2 and 3. So now we have two cases here. So we either have, so the first one being that 2 is equal to 3, which then implies that 4 is our fake coin, or we have the case of where 2 is not equal to 3, which then would imply that 3 is our fake coin. So the reason why we can come to that conclusion here is because, so in case 1, so we said both of these are equal. So the 4 coins, we're assuming 3 has the same weight and 1 different. All right, so we have that there. But now we have something else that could happen. So this is just one path this could take. Well, case 2 is that 1 is not equal to 2. Okay, so if 1 is not equal to 2, then what we should do is try to compare the other ones. Or actually, well, we don't need to compare the other ones because we know that both of those would be the same. So let's just say that. So that implies that 3 is equal to 4. All right. Well, then we do that same thing that we did over here. So we're going to take just one of the coins that are the same and then see which one is. So let's take 2 and 3. So we'll have 2 and 3 here again. So then this is going to be broken up into two different things. So we could have 2 is equal to 3, which implies that 1 is fake. And then we have the case of where 2 is not equal to 3, and then this is going to imply that 2 is fake. And well, you can see that it doesn't matter in each case. Well, how many weighings did we do? So we weighed 1 and 2 here, so that's one weighing. Then we come down here and we did a second weighing. So we did 2 weighings. For this. And if we have at least 2, then we should be able to figure out which one is the fake no matter what. All right, so let's actually kind of write out what this algorithm was though. So what we do first, so we'll just call them coins 1, 2, 3, 4. So first, compare coins 1 and 2. If 1 is equal to 2, then compare either with coins 3 and 4. So if 3 is the same weight as the other, or as either coin 1 or 2, then 4 is the fake. But if 3 is not the same weight as either 1 or 2, then 3 is our fake. All right, so that's for the first case. Now, the second case is going to be, so this is case 1. So now for case 2, we're going to have, so if 1 is not equal to 2, then 3 and 4 must be equal. So compare coin 2 with either 3 or 4. And then if 2 is the same weight, then we will have the case that 1 is our fake. But if 2 is not the same weight, 1 or 2 is the fake. So that would kind of be our algorithm. And if you want, you could write this a little bit more computer sciencey, but I feel for the most part this kind of gets the algorithm's point across.